Okay, so welcome to the lesson 1 of Unit 3, and the focus of this lesson is going to be on the angles of a polygon. When we talk about a polygon, what we're going to do is focus exclusively on convex polygons. And so an example over here of a convex polygon, we have a convex quadrilateral over here, and to the right we have a non-convex. The way that you know that it's a non-convex polygon is that you can join two interior points with a segment that passes outside and then back into the polygon. The rules related to the angles of a non-convex polygon are different to the rules for a convex, and in our curriculum our focus is only on convex polygons. Okay, one of the important piece of information we need from previous units is, of course, that the angles of a triangle add up to 180 degrees. So the angles of a triangle add to 180 degrees, and we're going to use that information to develop our rule for the sum of the interior angles of convex polygons. Okay, so polygons, as you can see here, are named by listing their vertices, so consecutive vertices in order. So we could name this quadrilateral HGFE, for instance, and what we have is a new definition, if you will, called a diagonal. And what a diagonal does is it joins non-consecutive vertices of a polygon. So of course, if E were to join to H, those are consecutive vertices, and segment EH would not be a diagonal. It would in fact be a side of the quadrilateral. So the purpose of having a diagonal is that it divides the internal area of a polygon. In this case, a quadrilateral, a four-sided polygon, if you draw in a diagonal, it's going to divide the polygon into two triangles. Of course, using the sum that I mentioned before, the sum of the measures of the angles of a triangle is 180. And what we can therefore conclude is that the interior or internal angles of a quadrilateral will add up to 360 degrees, and that's because it can be divided into two triangles. Notice a couple of important things. First of all, diagonal EG does not necessarily bisect angle E or angle G. It's possible that it does, but that's not for sure. And the 360 total is angle H plus G plus F plus E. And none of those are necessarily equal to each other. So it's the sum of the interior angles of a quadrilateral is 360. So the idea now is we're going to look for a pattern. We're going to go to a pentagon. And so a pentagon is our five-sided figure, 5 vertices, 5 sides. If we draw diagonals, you can see that what we're going to be able to do is divide this into 3 triangles, and therefore the sum of the interior angles of a pentagon is going to increase to 540 degrees. And in the third example, 1, 2, 3, 4, 5, 6, we have 7 sides. That's named or called a septagon. If we have 7 sides, you can see 1, 2, 3, 4, 5 triangles. Once again, each 180 degrees. And we can then figure out the sum of the interior angles of a septagon. So we have essentially 5 times 180, which is 900 degrees for the sum of the interior angle. And this should allow us to develop a pattern. And so what we can see here is that when we had 4 sides, we had a quadrilateral, and the total was 360. 5 sides was our pentagon. Okay, and what I'm going to do just for a moment is pause the video and just fill this in just to save a little bit of time. Okay, so welcome back. So I've just filled in the table with what we'd already ascertained. So the idea now is we're going to take a look at the pattern. As we increase the number of sides 3 to 4, 4 to 5, 5 to 6, what we can see is each time we are adding 180 degrees to the total, and that pattern continues. We then jump to 8, 10, and then in fact to an n-gon, and n-gon is a polygon with n sides. So the idea is to generalize the rule at this point. And what you should hopefully see that for a triangle, it has got 3 sides and will have 1 triangle. A quadrilateral has 4 sides and can be divided into 2 triangles. Pentagon, 5 sides, 3 triangles, and hopefully what you realize is that the number of triangles in a figure is always 2 less than the number of sides, and this allows us to generalize the rule to n minus 2 times 180 to get the sum of the interior angles of a polygon. Okay, if we jump ahead, here we have theorem 6.1, which says exactly that. If you want to find the sum of the interior angle measures of an n-sided convex polygon, the formula is n minus 2 times 180. Okay, what we're going to do is move on, and I'm going to take just a moment to explain the next theorem, which is the sum of the exterior angles of any polygon. And what you can see here is the sum is always 360 irrespective of the number of sides. Okay, so a little bit of algebra quickly to show you why it is that that is the case. And so if we want the interior angles, we know that the interior angles sum is going to be n minus 2 by 180, which if we distribute out gives us 180n minus 360. What we can do is we can figure out that if we want the total sum, the total of both the interior and the exterior angles of a polygon, this would be 180n. And the reason for that is, if you look at this diagram, for each of the vertices of a polygon, we would have, remember, an exterior angle is formed by extending one of the sides. And so for each of these, we have a linear pair. That means we have 180 degrees at each of the vertices if you want the sum of both the interior and the exterior angles. And that means 180n would give you the total of the sum of interior and exterior for any polygon, depending on the number of sides. If you now want to figure out just the sum of the exterior, then what we can do is subtract those two. So we're going to take the total, which is 180n. We're going to subtract the interior sum, which is 180 minus 360. And what you should see over here is that the 180n minus 180n will cancel out. And then we distribute that minus sign and we get plus 360. And this allows us to see or to confirm that the sum of the exterior angles of a polygon would be 360 irrespective of the number of sides. Okay, last important concept that you need to understand is the idea of a regular polygon. Regular polygons are both equiangular and equilateral. So we've already dealt with an equilateral triangle. It means all of the sides are equal and all of the angles are equal. This applies to all quadrilaterals, I beg your pardon, to all polygons if they are termed regular. Okay, so let's move on and see what kinds of calculations this is going to throw up for us. So first example, a polygon has 32 sides, so that's the n value. We've been asked to find the sum of the measures of the interior angles and the sum of the measures of the exterior angles. So we can begin with the exterior. So the sum of the exterior is simply going to be 360 because that is doesn't rely on the number of sides. For the sum of our interior, we are going to have our formula 32n minus 2 by 180. So that's got 30 triangles inside, which we then multiply by 180. And so 180 times 30 gives us a total of the interior angles of 5,400 degrees. Okay, now in this next example, we need to pay attention not only to the number of sides, n, but also to the fact that it's regular. And what we've been asked to do is to find the measure of each interior angle. We're able to do this in a regular polygon because if we can find the total number, we can divide by the number of angles because they'll all be the same. So again, imagine an equilateral triangle. The total angles add up to 180, but we divide by 3 if all 3 of them are equal, and this principle extends beyond triangles. So using the interior angle formula, essentially what we're going to do is find the sum of the interior angles, and then we're going to divide by the number of angles. Oh, let's write that, which essentially gives us the following formula. N minus 2 times 180 gives us the sum of the interior, and then we divide by n for the number of interior angles. And so now we just have to substitute in 12 sides minus 2 multiplied by 180 divided by 12, which is the number of sides. And so we end up with 1,800 divided by 12, and that gives us each interior angle of 150 degrees. There is an alternate method that we can use, and that is using the exterior angles. Since we know the sum of the exterior angles is 360, we can say 360 over n, which is in this case 360 over 12, gives us 30 degrees for each of the exterior angles. And as mentioned in the explanation above, exterior angles are a linear pair with the interior angles, and therefore the interior angle is simply going to be 180 minus the 30, which gives us 150 degrees. The same answer as above, a little less work and slightly faster. Okay, moving on to our next example. We have the sum of the measures of the interior angles of a polygon is 6 times the sum of the measures of the exterior angles. And then the question is asking how many sides. So once again, let's focus on what information is given and what we're trying to solve for. So if we have the sum of the measures of the interior angles of a polygon, that is simply n minus 2 by 180. And we are told that that is equal to 6 times the sum of the exterior angles, in other words 6 times 360, and all we need to do in this case is solve for n. Okay, so starting to run out of time, so I'm just going to pause the video there and I'm going to do that calculation separately, and then I'll show you the answer. Okay, so what I've done is just written out, so I've expanded out the 180, multiplied 6 by the 360, moved the 360 and divided by 180, and we have our answer, n is equal to 14. Okay, next problem. So in this particular case, we've got a pentagon with each of the interior angles. What you may not do is assume that any of these are equal to each other, because we were not told that it was regular. And so what I need to do is add all of those angles up. And in this particular case, if I draw diagonals, reasonable diagonals, we will be able to ascertain very quickly that the total of the interior angles is going to be 540. And so that's 540 is equal to the sum of all of these angles. So once again, I'm just going to pause to do some of the writing. Okay, so I've worked the problem now. Let me talk you through it very quickly. So we had 540, which was the sum of the interior angles, equals the sum of all of the angles. That simplifies to 21x plus 15. Move the 15 over, divide by 21, and that allows us to see that x is 25. And the final step, of course, is to answer the question. Find the measure of angle ABC, which is this angle over here. We substitute in the 25 and get our final answer of angle ABC equal to 95 degrees. Okay, on to the last example with about a minute to spare. And so this question is asking for the number of sides. Again, pick out the key information. It is a regular polygon, and we are given the measure of an interior angle, and that's 171. So again, I'm going to use the efficient method this time. If an interior angle is 171, that means the exterior angle is going to be 180 minus 171, which is 9 degrees for the exterior angle. And then if I want to know the number of sides, we have got 360 over n, gives you the measure of each exterior angle in a regular polygon. If that equals 9 degrees, then what I'm going to do is just switch those around, get 360 over 9 is going to give me the number of sides, and therefore the number of sides in this polygon is going to be 40.